Okay, so in this problem, you're asked, it says, which of the following functions would have end behavior? So this time you're looking at the end behavior of these functions, but which would have end behavior that falls on both ends. So just a reminder, when you looked at the videos that went with those lessons or in class when we partially talked about this, so when you have a polynomial function or a polynomial function, the graph of a polynomial function is continuous. So meaning that when you look at these graphs very quickly, one of the polynomial functions that you've graphed before was a quadratic polynomial function. So it went up something like this, or it could have gone down, right? It could have opened down. All right, so that's a continuous function. There are no breaks at all in the graph. You take your point, it continuously flows. There's no jump in the graph. It just continues on. Okay. Um, and the other point for a polynomial function, the domain is all real numbers. That's a domain of a polynomial function. So notice when you take your ruler and you go from left to right, you'll go from negative infinity to positive infinity all along the cases. Now the range is not the case. The range depends on many characteristics. For example, remember a quadratic function has a minimum or a maximum. But that's an example of a polynomial function. Another one would be something like this, where you have something that could do this. Okay. So you have this polynomial function that's a continuous polynomial function. One of the things you have to notice is that on the ends of these graphs, you have arrows. All right, and remember, continuous function, the domain's all real numbers, so it continues on in both directions, going from left to right. Notice that on this particular polynomial function, the end behavior, the behavior in the ends, just basically look at the arrows, they're pointing up. They're up on the left, up on the right. Over here, end behavior, pointing up. Over here, pointing down, right? You could have something that looks like this, a polynomial function that maybe looks like this. Okay, notice the end behavior. It doesn't matter what happens between them. We don't care about that. In this particular topic, we're only interested in the end behavior. And to determine the end behavior, it's very easy to determine, regardless of what these polynomial functions look like. It is very easy to determine what's going to happen on the ends. You won't be able to determine what happens between them. That takes either a graphing calculator, or if you don't have access to a graphing calculator, which in this course you don't, but in future courses like in calculus, you could use derivatives to help you determine what happens between those end behaviors. So notice on this particular polynomial function, the left side, notice I'm using the word left side for us, the left side points up, the right side points down. All right, so those are the end behaviors we're talking about. You're not worried anything about what happens between them. Okay, now the best way, to help you determine those end behaviors is to consider, always think about these two functions that I'm about to graph. So the first one is going to be y equals x squared. So when we look at y equals x squared, and if you don't remember what it looks like, hopefully you do, but use a t-table. So when x is 0, 0 squared 0. When x is 1, 1 squared is 1. When x is negative 1, negative 1 times itself is 1. When x is 2, 2 squared is 4. And when x is negative 2, negative 2 times negative 2 is a positive 4. So when I look at this, I'm going to apply these points 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and so on. So remember this, the parent function, remember that's a parent function, right? Y equals x squared. So y equals x squared points up. Notice the end behavior on both sides. So the end behavior, you would say on the left, it goes up. On the right, it points up as well. Okay? Now, another thing that should help you is this. Now, I'm going to do it on this one. Y equals negative x squared. Now, remember, we talked about the idea of reflection. So remember, this is reflection about the x-axis. So you're taking the parent function, which is this, and you're reflecting about the x-axis. And so when you reflect about the x-axis, notice that the x-coordinate stays the same, the y-coordinates become opposites. So remember this point here was 1, 1. So when you reflect it about the x-axis, it becomes a point 1, negative 1. All right. But if you didn't remember the idea about reflection, hopefully you did, use a t-table. Use a t-table. If x is 0, 0 times itself is 0. The opposite of 0 is 0. If x is 1, 1 squared is 1. The opposite of 1 is a negative 1. See that? 1, negative 1. That's this right here. When x is 2, 2 squared is 4. The opposite of 4 is a negative 4. Negative 2. Negative 2 times itself is 4. The opposite of 4 is a negative 4. And so basically you get these points right here. 2, 2, negative 4, and negative 2, negative 4. So you get this. All right. Now the point being this. So it helps in your mind when you get to the idea of the end behavior of polynomial functions in your mind, have the notion of this graph and this graph. Okay. So notice that for x squared, the end behavior, they're pointing up. For negative x squared, so that's that coefficient. So notice the coefficient here is negative, negative 1. So negative coefficient, it points down. All right, now the other thing you got to remember is this, and listen carefully. So we're going to talk about the degree of a polynomial. The degree of a polynomial. All right. So the degree of a polynomial. So the degree of a polynomial, I'm going to put this in one variable because that's what we're going to be dealing with, in one variable. So the degree of a polynomial in one variable, so a polynomial function, let me put polynomial function. The degree of a polynomial function in one variable means something like this. So we're going to start with an example. So let's say we had f of x equal 3x to the fifth minus 4x squared plus 7x plus 2. So notice that this polynomial function, that's at one variable. So notice that the only variable you see is x. So that's what we mean by one variable. Okay, that's important. One variable. All you see is x. So since it's one variable, it's easy to determine the degree. The degree is at largest exponent. The degree is largest exponent. So I'm going to put the word largest exponent here. Okay, largest exponent. So the degree of this polynomial, the degree of f of x, is 5. Okay, so the degree is 5. So the other thing we can say is that the degree is odd. The degree is odd, right? Okay. Now, I want you to also tell me about the coefficient of that largest degree term. So here's my largest degree term right here. The coefficient is positive 3. So I need for you to tell me right here, when you say the degree is odd, I want you to tell me the leading coefficient is positive. Okay. All right, so that's what we mean by the degree of a polynomial in one variable. The degree of a polynomial in one variable is the largest exponent. So the degree is 3. Now to help you with this end behavior though, not only do you need so to determine end behavior, all right, so to determine end behavior, you need to know the degree of the polynomial and two things: the degree of a polynomial, and you need to know the sign of the leading coefficient. Okay, all right. So right here, so all I'm doing here is just trying to get you to see what the degree is. Now remember, we're only dealing with one variable, so notice all you see is the variable x. So the degree is the largest exponent, and to help you with determining end behavior, also look at the leading coefficient, the sign of the leading coefficient. So the leading coefficient is 3, the sign of 3 is positive. All right, here's another quick example. Suppose we had g of x equals 7x squared minus 3x plus 4x to the third minus 7x to the fifth. Oops, let's do 6. 7x to the 6. Okay. Now, so here you have this polynomial. It is not in descending order, so you have to be careful. So don't say the degree is 2. Remember, the degree of a polynomial in one variable is the largest exponent. So the largest exponent is 6. So the degree of g of x is 6. Okay? All right. So notice the degree is even, which is even, right? Degree is even. Then, to answer the idea that in behavior, I need to also look at the sign of the leading coefficient. So the sign of the leading coefficient, now here's your leading term. Remember, leading term doesn't always mean the first. Leading term, your leading term is the term that has the largest exponent in one variable. Okay, so I need to be careful when I say that. So the leading term is a term that has the largest or that has the largest degree. We put the word degree. That has the largest degree. The coefficient here, be careful. The coefficient is not 7. The coefficient is a negative 7. So the coefficient of the leading term is negative 7, which is negative, right? Okay, negative. All right. Now, just to say something else, you could have now in a previous. Now remember, when we're dealing with functions. We're dealing with functions, and we graph functions in a plane. We're only dealing with one variable. All right. But just to in a previous course, you learned about this idea. So here's this polynomial. Okay, here's this polynomial, and let's say we had 2x squared y plus 3x cubed y squared plus 6x squared y to the fourth plus 7x cubed, something like that. Okay, and you want to find the degree of the polynomial. Now remember, we're dealing with functions, so when we deal with functions, we're dealing with just one variable in the process. All right. Okay, but here in general, when you're dealing with just a polynomial, see that's a polynomial. When you're dealing with polynomials, to find the degree of this polynomial, you look at each term, one term, two terms, three terms. Let me put a subtraction here, and another term. First of all, what you had to do is add the exponents. So this is 2, this is 1, the degree is 3. You add them up. Over here, 3 plus 2 is 5. Over here, 2 plus 4 is 6. Over here, there's only one variable. The degree of that term is 3. So here are the degrees of each of those terms. The degree of a polynomial is the largest of these. So the largest of these is 6. So the degree of this polynomial, is 6. Okay, so you learned something of that when you took a previous course, but in our situation, since we're dealing with functions, don't look at this. You need to understand this, because when we graph functions, you're only graphing functions with one variable. All right, now let's go back to this. So y equal x squared, the degree is 2, so that's even. Okay, degree is 2, that's even. Y equal negative x squared, the exponent's 2, so that's even, right? Put the word even here. Okay, even. Now here's what I want you to remember: when the function has an even degree, it's always going to be the case where the end behaviors will point in the same direction. So notice y equals x squared, they're pointing up. Y equals negative x squared, they're pointing down. Okay? All right. Now you may say, well, what makes them point up? Well, what makes them point up is the coefficient of x squared, the leading coefficient. So the leading coefficient is a positive 1. So since the leading coefficient is positive, they point up. Here, the leading coefficient is negative 1, negative, points down. Okay? So we're going to go ahead and write this right here. So we're going to say if the degree is even, The end behaviors point in the same direction. The end behaviors point in the same direction. Okay? So they're going to point up or they're going to point down. Okay? Does not matter what happens between them. I don't care anything about that. I just want to know what happens from the ends. All right? If the leading coefficient is positive, they point up. If the leading coefficient is negative, I forget the word coefficient. If the leading coefficient is negative, they point down. Okay? So this will be leading coefficient positive, leading coefficient negative. Okay? All right. So that's the first one. Degrees even. All right. So when you get to a point, when you get to the point where you're looking at the problem that deals with the end behavior in your mind, always think of x squared, negative x squared, and the other one you need to know is this one, y equal x cubed versus y equal negative x cubed. All right, so let's look at y equal x cubed, and let's plot some points. All right, so when x is 0, 0 cubed is 0. I'm going to plot that point 0. The ordered pair 0, 0. When x is 1, 1 times itself 3 times is a positive 1. So 1, 1 right here. When x is negative 1, a negative 1 cubed, be careful, negative 1 cubed is a negative 1 times a negative 1 times a negative 1, which is a negative 1. So negative 1's here. When x is 2, 2 cubed is 8. So 2, 8, right here. When x is negative 2 cubed is also is a negative 8. So 2, negative 8. So I'm sorry, negative 2, negative 8, right here. Okay, and so you get something that looks like this. Now, notice this is an odd function, right? So that's an odd function because it's symmetric about the origin. So this graph is supposed to be symmetrical about the origin, so that makes that an odd function. All right, so that's what the y equal x cubed looks like. So for y equal x cubed, and if you remember this, on the left it points down, on the right it points up. Okay. So notice the degree in both cases is odd. The degree is odd, right? So when the degree is odd, the end behaviors point in opposite directions. So B, if the degree is odd, the end behaviors point in the opposite directions. Okay? All right, now, if the leading coefficient, we did this one already, y equal x cubed, the leading coefficient is positive 1. So if the leading coefficient is positive, okay, the leading coefficient is positive, on the left points down, on the right points up. Okay? On the left, it's always in your mind, think about y equal x cubed. Here's y equal x cubed. On the left it points down, on the right it points up. And so in general, whenever you have a function that has an odd degree, on one side is going to point up and does not matter what happens between them, does not matter, and on the other side it'll oops, I did not mean to make it sharp. Okay, it's a smooth curve, and on the other side it points down. So notice pointing up, pointing down. So this right here would be a function with an odd degree. All right. So You know it's a function with an odd degree. You don't know what that function is. You just know it's a function with an odd degree because on the left it points up and on the right it points down, opposite directions. Okay? All right? Just like this. On the left it's going to point down. On the right it points up. So you know it's a function with an odd degree. I didn't say an odd function, okay? An odd degree. So always be careful with the terminology, with your words. So this is a function with an odd degree. Okay? Now, I'm going to ask you about the leading coefficient. You don't know what the function is. Okay? You have no idea what the function is. You just know it's a function with an odd degree, meaning that the largest exponent is odd. The largest exponent is odd. I'm going to ask you about the leading coefficient. Is the leading coefficient positive or negative? Well, remember, on the left it points down, on the right it points up, so that means the leading coefficient is positive. And we know that because of what we just drew. Y equal x cubed right here. Notice what this looks like. On the left it points down, on the right it points up. Now let's look at this one. So what do you think happens with negative x cubed? Remember, the negative out here is that reflection. So if you don't remember that, just use a t-table. Now be careful with the negative x cubed, with the negative, because the only thing that's being cubed is x, not negative x. Alright, so if x is 0, I get in parentheses 0 cubed. 0 cubed is 0, the opposite of 0 is 0. When x is 1, I get this. 1 cubed is 1, the opposite of 1 is a negative 1. When x is negative 1, I get this. See that? Negative 1 is being cubed. Negative 1 cubed is a negative 1, and the opposite of a negative 1 is a positive 1. When x is 2, I get this right here. 2 cubes 8. The opposite of 8 is a negative 8. Negative 2, the opposite of a negative 2 cubed. Negative 2 cubed is a negative 8. The opposite of a negative 8 is a positive 8. And notice when I plot those points, 0, 0, same as the other one. 1, negative 1 is down here now. See that? And 2 negative 8's down here. And negative 2, negative 1, 1's right here. And negative 2, 8 is up here. So notice the difference. I'm going to try and use a different, I'm going to use a highlighter. So it looks something like this, right? That's what that will look like. Okay, so notice this right here is y equal negative x cubed. So the points being this. So notice that in both cases the degree is odd. So notice in both cases, in the black graph, opposite directions, the highlighted graph, opposite directions. Notice that in the black graph, on the left it points down, on the right it points up. That's because the leading coefficient is positive. If the leading coefficient is negative, on the right it points up, on the left it points down. Okay? All right. Now let me go back to this now. Let's finish this one up right here. So we know that if the degree is odd, the degree of the polynomial function is odd, the end behavior points in opposite directions. If the leading coefficient is positive, the left side points down, the right side points up. If the leading coefficient is negative, it's just the other way. On the left, it points up. On the right, it points down. And remember, don't memorize this. Never memorize something because you're never gonna really learn it. Right, it points down. The best way to do it is like I just showed you here. Think of x cubed, negative x cubed. Quickly, you in your mind you have what the graph looks like. So that's odd degree, even degree, same directions. Positive coefficient points up, negative coefficients points down. All right. Most students have an easier time remembering a function with an even degree versus a function with an odd degree. Okay, so now I think we can go to this. Okay, so now let's go and quickly do the end behavior. So the end behavior falls on both ends. All right, that's the one you want. All right, so let's look at each one. So notice here I have that always remember the degree. To answer this question, you need to know the degree. The degree is even, the largest exponent. And then you look at the leading term, which has the largest exponent, and you ask yourself, what's that sign of the coefficient? So the degree is even. The sign of leading term is positive. So since the degree is even and the sign of the leading term is positive, the end behavior will be well, since the degree is even, the end behavior will be pointing in the same direction, either up or down. But since the coefficient is the sign of the leading coefficient is positive, they're going to be pointing up. Okay. So what's the end behavior on both sides? You're going to see both sides point up. That's your answer. So the answer, both sides point up. Okay. All right. Now let's see this one. So in B, you look at the first of all, you got to find your degree. So what's the degree of this function? Well, that's that largest exponent, so that's 6. So the degree is 6. So the degree is even, right? The degree is even. So remember, the degree is even means that the end behavior is going to point up or point down. So it's either going to point up or it's going to point down, right? Okay. Now, in order for it to point up, remember what happens if it points up? We already did one. If it points up, that means the sign of the leading coefficient. I should say leading coefficient here. The sign of I'm sorry, the sign of the leading term. Or it doesn't matter. Leading term, leading coefficient, because that's what it is. All right. Sign of the leading coefficient here was positive. Over here, the sign of the leading coefficient is negative. So since the sign of the leading coefficient is negative, it's going to point down in both directions. All right. Sign of leading coefficient is negative. All right. So that's going to be this one. And so you're going to say answer. Both sides point down. Okay. All right, let's go to the next one. So here we have this polynomial function. So we got to first of all find the degree. The degree is even. It's 10, right? The leading coefficient, the sign of the leading coefficient is the leading coefficient is -8, so the sign is negative. All right. So remember, since the degree is even, it's either going to point up in both. Well, in both. So the degree is even is going to point up, right? So it's either going to. I'm sorry. Since the degree is even, the end behavior will point in the same direction. So either it's going to point up or it's going to point down. Since the leading coefficient is negative, it's going to point down. So this one's going to be this one. So answer, both sides both sides point down. Okay, over here, and let's get this one. So here, the degree is odd, right? The degree is odd. Now, the direction says which one falls, which of the following has end behavior that falls on both ends. Well, obviously, you can say you can eliminate this one, couldn't you? Because the degree is odd. If the degree is odd, the end behavior is in opposite directions. End behavior is in opposite directions. So either it's going to point up on one side, point down on the other, or point down on one side, point up on the other. Okay? So you can eliminate this one right away, but let's continue talking about this one. All right, so just kind of review something. If the degree is odd, we know that the end behavior is in opposite directions. Now we have to look at the coefficient of the leading term. So here's the coefficient of the leading term. Remember, that's your largest exponent. The coefficient of the leading term is negative. So the coefficient of leading term is negative. So in your mind, whenever you see this, a polynomial that has an odd degree is always the hardest for students. So what you want to do then is think about, since the leading coefficient is negative, think about what negative x cubed looks like. So negative x cubed is the one that does this. Okay, that's what negative x cubed looks like. So on the left it points up, on the right it points down. All right. So on the left it points up, on the right it points down. So that's the one you're going to use for that one. All right. So if you were given this and you ask, and all you were asked is what's the behavior, you would say the behavior on left points up, comma, on right points down. Okay? All right, now let's go back and answer the question here. What is the end behavior? So which of these functions, I gave you four of them, which of these functions would have end behavior that falls on both ends? All right, so we saw that this one, both sides point up, meaning that it doesn't fall, it rises on both ends. So I put the word rises on both ends. Since they use the word falls, I'm going to put rises on both ends. So it's not that one, right? Over here, points down, so meaning it falls on both ends. So that's one of them, right? So you're going to circle this one. So that's an answer. That's an answer to this question. Over here, this says answer both. So for this function, it both sides point down. So you're going to, so that means falls on both ends. So there's another answer, right? And this one obviously we could eliminate right away because that was an odd degree. All right, so in order for it to fall on both ends, first of all, it has to be a polynomial with an even degree. So we could eliminate this one right away. And the only choices left with those three, and we had to go and analyze each one of those. All right, so that is it. That's a quick review of one area of polynomials that was in those video lessons that you had to look at. All right, so one topic when discussing polynomials, one topic that we always talk about, the first few topics that we always talk about is what's the end behavior of a polynomial function, and that's what this is. Okay, and so on your test, you are going to have an example where you are going to be asked what's the end behavior. So it's very important that when doing that, you always remember this idea right here: x squared, negative x squared, x cubed, negative x cubed, and that will help you to answer something like this. You also need to know, though, this idea here. If the degree is even, the end behaviors point in the same direction. Either point up, so they rise on both sides, or fall on both sides. Or if it's odd, they're going to be in opposite directions. Either on the left side it falls, on the right side it rises, or the coefficient is the leading coefficient is negative. On the left side it rises, on the right side it falls. That one's a little bit more complicated for students to kind of understand, but when you take this and you align it with this, with x cubed, negative x cubed, it's easier to remember, it's easier to understand. Okay, so that is it. So that is our topic on understanding something about the end behaviors of polynomial functions.